let's get started. A block of mass sliding at a constant velocity down inclined plane that makes an angle of 37 degrees with respect to the horizontal. So what is the friction force? What is the coefficient of kinetic friction? So the first thing we need to do is, to draw the free force body diagram. So we can have it here. This is, and then we have the block is here, right? And this angle is given as 37 degrees. Then we have it's 5 kilograms, so 5 kg. That's not very good. Yeah, 5 kg. With respect to the horizontal. So with the free force body diagram, the next thing we proceed to do is to draw all the forces acting. So we have the weight acts directly downwards, and this means it's mg, so it means it is fg for the weight. And then we have the friction force is in this direction, so this is the friction force into that direction. And then finally we know there will be a horizontal component of force that is towards this direction, so we're going to call it F parallel. Parallel means it's parallel to the slope, like that. So we also know there is the normal reaction force acting upwards. That's Fn for normal reaction force. And therefore, if we can join these forces, we will have them as follows. So this angle we see is the same as this angle here, which let's for now call it theta. And therefore, given this is Fg, which is, we know this is a weight given by mass times gravitational field strength. This is the normal force, so just draw the N. Okay, this is same as normal force there. And we can now rewrite both N and the Fp. So Fp is the horizontal component of the force that is parallel to the slope. So with that, let's rewrite these two forces and say Fp is equals to, that is Fp opposite, so that means it's going to be sine from SOHCAHTOA. So from the SOHCAHTOA, each time you have the opposite and the hypotenuse, so the opposite here and the hypotenuse to Fp, so opposite and hypotenuse, we're gonna have it as that is Fg sine of theta, which we know automatically this means mg, that is 5 times 9.81, then sine of 37, that will be our value there. And then we have the perpendicular component, which is normal reaction force to the slope. So our N here will be, that is Fg cosine, this is adjacent. The angle and N are adjacent to each other, and then hypotenuse. So adjacent and hypotenuse, that means we have Fg cosine of theta, implying Fg again is the weight, which is 5 kilograms multiplied by 9.81 cosine of 37 degrees. So can we have those values with your calculator? Give me these two values. So 29.5. All right. And what about this other one for the normal reaction force? So 39.117 newtons. So with that, we are told that it moves with a constant velocity, so sliding down. So it means now we know First of all, along x, so along the x-axis, we can simply say, applying the Newton's laws of motion, the sum of the x from I0 all the way to n, so it means Fi along the x is equals to 0, simply because this block is moving at a constant velocity. In other words, we know it should be m is equals to ax, but acceleration here, acceleration is equals to 0. And how we know that is because of constant velocity there. With that, it means if I add my Fp, so my Fp, and then you add, that is on the negative side, the Ff, you should get a 0. You should get a 0. So that's all we have along the x-axis. But the question is the friction force, this Ff, which is the friction force. So how do we get the friction force? As usual, we've said always, for a moving object, it is the kinetic coefficient of friction times the normal reaction force. So we know we're not given the UK, which is the static coefficient of friction, but now we have our N, which is here, so multiplied by that 9.17, and that means is equals to that 9.17 mu k. That's our friction force. So according to our equation here, we've said when it is sliding down, so we're gonna have this, we're gonna have Fp plus Ff is equals to 0. Fp is given, we've already sorted that one out, and therefore we just substitute into the equation. So Fp, which happens to be the force parallel to the slope, so this is so Fp, we got it there, that is 29.5, and then subtract Ff, which is here, 39.17 mu k is equals to 0. So balance both equation and you get 29.5 is equals to, taking this to the other side, that's 9.17, and then we have mu k. So mu k, you divide both sides by that 9.17, and then what do you get? So 0.75. Remember again, it has no units, just a constant value. So that's it. So to clarify, the N here is the unit. So this is the unit Newton. And the N here, we are referring to the normal force. So the normal force, that is the normal. So capital M is 10 kgs. So this one here is 10 kgs. Is connected to another block of mass that is 1 kg. And then as shown, there is no friction between the surface and the block with mass M. What is the acceleration of the system and what is the tension force? All right, we can isolate them, this to be one system and this to be the other system. So just draw a line here to isolate the two. And then with that one, the tension force in this direction, T, and the tension force here, T, is the same. So T here and T here. So for this part, since tension force is the one pulling the box into the right direction, and we don't have any friction force to the left, so we're gonna say from Newton's second law of motion, the F net should be equals to the mass, that is of course to the in the x direction, mass times acceleration in the x direction. So the F net, we only have one force, we don't have force on this direction, so no force to the left. so to the left, so therefore we only have this force, and therefore T only is the resultant force or the net force. So we're going to say T is equals to the mass, which is 10 kilograms, and then you multiply by the acceleration into this direction. So that one will give us equation 1. So we come to this other side where we have okay, something more here. If you think about the forces which are perpendicular, they do not affect the system in any way at all because we don't have the friction. So even if you think like we have the normal reaction force into the system, that side, and we have the weight in this direction. So on the y-axis, so on this other system, so system 2, so we have first of all the weight. So this weight, we have the weight which is directly downwards, so the Fg, and of course we have this tension in this direction. So we need a way to combine these two. And if this system is accelerating, it's because of this mass here. Remember, we cannot add forces looking like this. We have to put them in the same line. So what we're gonna do is that we're gonna get the component, that is the component of weight, that is to this direction. Same, this is 45, so 45 degrees. And therefore, the component of weight into this direction will simply be Fg, and then the cosine of 45 degrees. So the F net for this system, so we have the tension in the upper direction, and then we have the that is the component of weight in the opposite direction. So we can apply Newton's second law of motion and say the F net is equals to, so this is the bigger force because it's accelerating downwards, so that is Fg cos 45, and then you add the other one in the opposite direction, meaning it will be minus the tension force. All right, so this one should give us mass of this block times the acceleration, which is the same. The acceleration of this block is the acceleration of this block. They are all accelerating the same way. So with that, we just need now to substitute what we know. This 1 times 9.81, which is the same value, cosine of 45 minus t. So minus t is equals to, again, 1. It's going to be 1 times ax, like that. And therefore, we're going to have our equation number 2. Equation number 2. So then we solve these two equations simultaneously. Since we have t here, we can substitute t. So we're going to say 9.81 cosine 45 minus t, which is here, 10 ax is equals to ax. And then this will be 9.81 cosine 45 is equals to, take this to the other side, gonna be 11 acceleration. So divide by 11 on this side, divide by 11 on this side, so this cancels. Acceleration becomes what? So 0.63 meters per square seconds. So now finally to find the tension is very easy because tension is here. So we just need to say from equation number 1, T is equals to what? 10 ax, and we know ax is this one. So tension force is equals to 10 multiplied by this value, which is 0.63, and therefore it will be equals to 6.3 newtons.